Good morning and welcome to today's debate, taking inspection beyond the assembly line. Inspection machines are the eyes and ears of the production line. The role of the AOI, SPI and AXI is evolving fast and bringing a wide range of challenges and benefits to assembly. More recently, automatic inspection has started to expand beyond the assembly line and into final box build. Here to discuss some of these changes is quite a distinguished panel. Towards the end of the line on the right is Keith Bryant, who's an independent consultant. Welcome, Keith. To his left, we have Carsten Salewski from Viscom. To his left, we have Kevin Youngs from OMRON. And to my right, we have Dave Bennett from MIRTEC. So welcome, gentlemen, and thank you for joining us today. So let me get started with my first question. How important is automatic programming now in modern systems? We'll start at the end with Keith.
Automatic programming is the key thing, not only for, let's call it the extra stuff within box build, but automation is becoming more and more important. We have more things to look at. We have smaller features. We need to go faster. We need to be more accurate. So automated programming and almost to the state of using artificial intelligence to monitor the results becomes a bigger and bigger, let's say bigger and bigger item. It doesn't matter whether it's AOI or whether it's X-ray. It's something that's needed more and more. And if we talk about moving into box build, then yes, it's a key feature because we're looking. Let's say printed circuit board is pretty two-dimensional, whereas you've got AXI and you're looking at a big three-dimensional information. You want to look at maybe 4 or 5 different layers within a box. The box is closed. You need very good programming skills to make sure that you're inspecting exactly what you need to see. And then you need very good algorithms to make sure that it's good, not bad. Right,
okay. Carsten, do you have a view on the automatic programming of these systems?
Yeah, Viscom is in the optical inspection industry for 35 years, and we started early on with safety-relevant electronics in automotive, so we're heavily involved with automotive electronics. And programming, let's say 30 years ago, wasn't a big issue because there was like a product was running for a year in high volume, and so you put in the effort once, and it's worth it because we have a zero defect environment. Today, product cycles become shorter, so more programming is involved, and we started a new software platform, user interface, to make it easier for the customer to, let's say, optimize the very complex algorithms that are behind defect detection. So yes, automatic programming is something we're looking into, where we engage artificial intelligence and big data to make sure that no defect is missed, and assist the operators, with making the right decision and optimizing programs.
Right. Okay. Where are the current technology barriers do you see it for inspection systems?
I think, rather than barriers, at the end of the day, Trevor, if you're looking at something and you're using the correct algorithms, you're using the correct lighting, you're using the correct cameras, you can inspect everything from a chair to whatever you want to look at. It's all about presentation, and when you present whatever you're trying to inspect to the camera, the difficult thing for us is that we do it too well. We're looking at sort of micron accuracy, and then somebody comes up and says, oh, here's a propeller shaft, can you inspect it? It's massive, and their faults are massive in comparison to what we're used to. So we actually have to, I am going to use the word dumb down, but it's a case of how do you present something that's not an SMT board to an inspection machine with incredible accuracy, a very tight field of view, and used to looking at minute details in micron level. When you go to the end of the line, are we going to be looking at the same sort of scale, or will we be looking at much grosser issues? And I think we're probably a little too accurate to look at some of the box build stuff at the moment. We have to sort of pull back the field of view. We have to change a lot. And a lot of things it's going to be down to how accurate are we working with the equipment. I mean, for example, if you have a robot, how accurately and how repeatable can it pick something up and present it to the camera? So can we do it? Of course, of course. Is it going to be easy? No, there's going to be some adaptation, but it will be driven by demand. The customers are going to say, this is a process, I need multiple machines, can you do it? The good news is, yes. The actual state of affairs at the moment is, it's not what the machines are designed for, but they can be adapted.
Okay. So Keith, it looks like, you know, we're going to be using, all inspection systems are essentially cameras, lighting, and software. But we're going to, if we're talking about the box build applications, potentially we're going to be looking at much bigger assemblies or bigger things to inspect. Is that going to be one of the challenges going forward?
Oh, definitely. It's one of the biggest challenges. The second challenge that we have is high reliability becomes a bigger and bigger issue for our customers. You know, when I started in this wonderful industry, a lot of stuff was put into a box. They poured resin into the box. The resin went hard and they closed the box. It was called potting, and it still is. And now more and more things are going back to being potted. You know, you look at things that are going into underhood environments for automotive, things that are going into the braking systems, some of the autonomous vehicle stuff. And then you look at all the other things that are going into harsh environments. So now we're back to a situation where we need to use X-ray in box build, because everybody wants a thermal, a really good potting compound that sets really quickly. It does all the stuff that everybody needs. But unfortunately, all of these things that move very quickly tend to shrink.
Right.
And if you've got components and you've got leads and you've got everything in there, you put it into a box, you flood the box with resin, the resin cures and shrinks, suddenly wires get pulled out of where they needed to be, components get damaged, things get bent, and then you need to have basically a final X-ray check to look through the box to make sure that you're seeing the things that you need to. You don't want to inspect all of the box because you just know the key points. So you need a good level of programming and probably also a good level of inspection knowledge to be able to see whether you have failures in, let's call them the areas where there are weaknesses.
Right.
So yeah, we have two levels. You have what's going on outside the box or whatever that you need to check, and then you have the need for X-ray to see what's going on inside the box, because obviously once the lid's on and it's been potted, the only way you can see what's going on is X-ray. So yeah, there are a lot of challenges out there.
So Carsten, you believe that we need for box build inspection, you're going to need a combination of 3D, AOI, and X-ray, because presumably it's got to be metrology based, because they're going to be looking at dimensional information.
That's right. You say one thing, it's not only inspection anymore. When I started 25 years ago, or over the 25 years actually, we had custom-specific optical inspection systems for motor controllers. There were 30-something cameras in a big box, and it was looking at a control device from all angles. You look at pin inspection, you look at even the label was inspected not only for position, but if there was the right barcode matching the program, everything. So we do that for a long time, and we see more and more of that, as you say, with electromobility, with 5G, with all these charging devices. There's a big need for X-ray inspection, because you have to bring a high current through a solder joint, and you want to make sure it's thermally safe.
Right. So,
and we can combine optical and X-ray for that. We have machines who have, both sensors in the same machine, and combine this. Regarding programming, when we have 3D data, it's more a measurement of 3D data. For example, we measure the volume of solder joints. I told you the other day. So our engineers say, yeah, that is 36 nanoliters of this solder joint, something like that. So that makes programming a little easier. If you have 3D data, you can easily classify good and bad missing solder or something like that.
Right. Right, okay. So, Kevin, let's move on a bit. I want to say that currently SPI, AOI, X-ray are collaborating. Will this extend in the future, do you think, to ICT and other test services on the back end, other post-reflow test equipment?
Well, yeah, it's a very interesting question, actually. Being OMRON, we are an automation company. Okay, the division I work for is for the inspection systems for the electronic industry. But of course, we're involved in all sorts of processes, food and commodities, other industrial manufacturing processes. So the interesting point for us is really where can a defect occur? So in reality, it can be from the supplier as soon as it comes through the door to the goods in, bringing the product through to the assembly line for the start of assembly. Of course, controlling the manufacturing process, different ways to do this with automation, of course, and the buzzword now, or the real technology, not a buzzword, is AI. So what does AI do? It finds data, it collects data, it examines, and it can give you a solution. The key there is for the manufacturing companies, well, what do they want to do with the data? Where in the process do they have defects? So I think that question that you bring opens up a bigger debate, because the end box solution, the final quality assurance, this is fine. So this gives you a holistical view of the manufacturing process.
Right.
And because the data then is the real intelligence would be used to improve the process, not just find defects.
Yeah. So currently, you can detect the defects, whether it's at the printer, the pick and place machine. Now I believe you can actually bring data back off of the oven, or the thermal profiling systems. The question really is, are we going to then move further down into ICT and other inspection systems?
I think you have to. I mean, we're all marching down the road of Industry 4.0. You can't leave this massive gap.
Yeah.
It's still part of the production. You have to start at A and finish at Z. You can't say, well, this part of the production is important. Nothing ever goes wrong there, because we all know it does. So if there's no need for ICT, then you don't need to have it linked. If there is a need for ICT or functional or any other type of testing, if there's a need for it, then of course it must be incorporated into the line, and it must be part of the 4.0 solution, that from the moment my materials go to my production line to the moment I put it in a box and send it out in the future, everything must be interconnected. Everything must be interconnected.
All right. So moving on from that, how important is it, Dave, to have a connection partner for legacy equipment? There's a lot of people out here that've got manufacturing lines that are not smart. They're quite old, some of them.
Yeah.
But they don't want to throw that equipment out.
No, of course not. They shouldn't have to. Yeah.
So how do they make this suddenly work with these new smart factory solutions?
There are connection companies who are able to take the majority of machines, whether they be brand new or whether they be legacy, and they can get the data that those machines are able to provide. Of course, some of the newer machines have got a far more comprehensive data reporting capability. Some of the older machines are quite limited, but the fact is they still have something. And there are specialist companies who for many years have been able to communicate with those machines. I think trying to reinvent the wheel is a bit stupid. A, there's too many manufacturers, and the idea that you can go to a customer and say, oh, I can give you a line solution, but you've got to buy this oven and that printer. I mean, that's lunacy. I mean, that's never going to work. You must be able to go to a customer and say, I will give you Industry 4.0, and I'll speak to all your legacy equipment. Right. And if you want to change in the future, I'll speak to that as well. And that's going to be done by integrators who are specialists.
Yeah. No, I agree. So, moving back to you, Keith, let's take a look now at what role AI is going to play in inspection systems in the future.
Oh, I always get the good questions. Okay. Artificial intelligence is going to become bigger and bigger and bigger in our industry. I think there isn't one person on this stage or probably in this hall who would say anything different.
Right.
How it does it and the speed that it does it is going to be the thing where probably you ask 4 people, you will get 5 different answers.
Right.
My view at the moment, artificial intelligence is something that's, the theory is great, but what it needs is data and information. Yeah? You can only get a good answer from something like artificial intelligence, however you want to play it, if you give it all of the information, and all of that information is accurate, real-time, and correct. And at the moment, we're not in a situation where we can supply that from all of the equipment that we need to. We can do it with some things. I mean, the guys who are sitting here, we are probably the closest to having an artificial intelligence solution. Yeah. But when you start looking at the data that you can get from a printer and the data that you would need to make, let's say, very good informed decisions without involving a person, we're a long way away.
Right.
You know, we all know a really good engineer will look at a print and he can tell you what's wrong with it. There may be 5 or 6 different things potentially that are wrong with it. If you look at that using artificial intelligence, even if you have an amount of fuzzy logic, even if you have an amount of machine learning, unless you have other data to support that print, you know, how much solder was on the, how much solder paste was on the stencil, was it wet enough, was it too wet, all of these things. If you could get that data and a print and give that to a machine, the machine is going to give you a perfect answer.
Right.
If you just give it a print, there's not enough data for it to make a decision. And that's really the holdback, from my view, at the moment.
Yeah, I think the thing is that what you're getting at is most of this AI is driven by algorithms. Algorithms make one decision, a yes or no decision, as we've discussed before. But I'm guessing that in the future you're going to be able to get a whole lot of these algorithms put together and educate the system to the point where it starts to make its own decisions. But at the moment, if it's just a case of making a choice between 6 different algorithms, which one it applies, that's not artificial intelligence. That's assisted intelligence. Artificial intelligence is when it starts to actually say, well, actually, I think, you know, the machine thinks this is the problem.
Yeah. But as I said, that needs data.
Right.
Yeah, and that's the missing link from some machines at the moment.
Right.
I mean, all of the guys sitting here where you have good quality, high-end AOI machines, you're getting all the data that you need. Position of the components, is the components correct, skew, solder joint information, and everything else. But when you get to, okay, pick a number between 60 and 80%. That's the number of faults that are generated as soon as the circuit board gets solder paste printed on it. Mm-hmm. And you can't get the data out of the machine that's doing the printing at the moment. Mm-hmm. And when we can get that, and I'm sure all the companies who make printers are moving towards being able to supply that, but when we get that, then yeah, artificial intelligence is really going to start to fly.
Well, that's one of the reasons I think we're going to end up moving to a dispensing-based system rather than a printing-based system, but that's a completely different discussion. Yeah. So, Carsten, what's your view on AI and its role in inspection?
Yeah, I think you started saying we're the eyes and ears, I think more the eyes of the inspection line. So we have the data, we generate the data, and finally we are able to store it in big data environments and use it. So there's already a high level of confidence in the testing and optical inspection, X-ray inspection results without artificial intelligence. Mm-hmm. So we can reduce the number of operators per line actually to 1 operator for 4 or 5 or more lines, mm-hmm. because false alarms go down, and if you have a decent process, that can be done pretty nice. So the next step is to use artificial intelligence to support the human. The biggest factor, or let's say probability to make a mistake in an automated line is the human being making the final decision on a potential defect. Mm-hmm. So we already start saying, okay, for certain component types, there is no human being needed to re-evaluated because we know it's very likely that we already did the right inspection. So we compare artificial intelligence in our environment a little bit to what happens with autonomous driving. There's the assistance level, so it keeps you on track, but that's far away from bring me to point B.
Correct.
If you have 5 stages of autonomous driving, I think we are right now at stage 2, where it's like a higher level of assistance. In the next years, and I would say 3 to 5 years, we'll see a lot more to go to autonomous
stage 5
inspection,
is still some way off.
Autonomous inspection, lights out factory if you want. So I mean, you can turn the lights out if you send the operator to the next room and do the remote stuff, but that's not what's meant by light out. So yes, I'm optimistic that we will see a lot of progress because we are finally able to process the data that we already have for many years.
Okay. So that kind of brings me on to my next question, Kevin, is the lights out factory inspection anyway, is that achievable in the near future?
In the near future, I think that's a little optimistic.
Yeah.
Being OMRON, we have AI. In fact, for our industrial division with the PLC, we have standard AI function blocks within our PLC. So we're now operating with system integrators and manufacturers in developing their processes. So what is AI? Okay, yes, it's a lot of information. And I think I'd like to say that all information is good information. I don't think there is anything that's called bad information. All information means that the manufacturer can make a decision. It's really how you quantify the data and understand how to use the data. And for that, the customer, the manufacturer, has to understand his process and what he wants to gain from his process. Okay, so what is our experience? Well, OMRON is a manufacturer as well. We have SMT lines. We have 3 SMT lines in Europe. Globally, we're manufacturing our products. And also we have a division that manufactures in automotive as well. So we start now this process of introducing AI into processes. So we have a real software now. We call it QR Porter. It's being installed into a customer in Europe. But it's using AI and developing the process step by step. So the idea is changing the way of thinking. Instead of taking data from inspection systems, we are now connecting to the process line. From the chip shooter to the oven to the printer. But in theory, it can be anything. It can be ICT. It can be beginning of the process. Yeah. So this is the concept. In the near future, well, the future is here, but how it's going to develop and at what speed really depends on technology, but also the customer really understanding his process. This is the key.
Right. Okay, Dave, I'm going to leave the last word to you.
Okay.
Are we going to have a lights out factory in the near future?
We were very close 20 years ago, Trevor.
Well, everybody was asleep.
I was actually involved working with some of the bigger companies when I was first involved with data control and also with optical inspection. Working with the Fraunhofer, it became very, very close to making a lights out factory. We didn't decide which country. It would probably have ended up in Germany. And I would have said we were probably 80% there from materials. The robotics were nowhere near as advanced, obviously, as they are now. AOI was nowhere near as advanced. But everybody knew how to take the first step. We knew how to take the first step. That's been lost. Suddenly we've got Industry 4.0, this great new idea. It was around 20 years ago. Right. And a lot of factories, people like Motorola, Ericsson, etc., they all had their own versions, and they were all looking at other people's versions to see who had the best way. So this is really nothing new. Near future depends on your scale. How close is the moon? Is that near compared to the sun? Yes.
It's true. It's interesting because the early adopters of all this smart factory business are the big companies, so the tier 1 companies.
Definitely.
Because they're going to gain the most out of it because they're doing the high volume and they've got the deep pockets to implement it.
I think one of the key things is our industry is renowned for running around the world looking for cheap labour. To me, as a manufacturer, that would be the first thing I would want to get rid of, that requirement. I don't need cheap labour, I need just a few really good people.
Really good people, yeah. Fascinating debate, guys. I'm afraid we're running out of time, but I want to thank you all for taking part. Keith Bryant on the end, independent consultant. We have Carsten Salewski from Viscom, Kevin Yuns from OMRON and Dave Bennett from MIRTEC. So thank you, gentlemen, and thank you for joining us today.
Thank you, Trevor.